Welcome back to my YouTube channel SK Tech. In today's video, we are going to discuss about another implemented class of the list interface, that is called linked list. And we are going to discuss about linked list interface, how does linked list work internally, method of the linked list, advantage of the linked list and disadvantage of the linked list with some example. Okay, so let's begin. So first, what is linked list in Java? So the linked list class extends the abstract sequential list similar to the array list, okay, and it also extends the list, dequeue and queue interface. So what is the meaning of the extending the list interface and then dequeue and queue interface? So basically, what are the functionality provided by the separate queue data structure, dequeue data structure and linked list methods are going to be by default available inside the linked list class. Okay. So by this we get that linked list data structure. Basically, linked list is implementation is provided on top of the linked list data structure. So what are the functionality is available in the linked list data structure is going to be available by the linked list class in Java. Okay, so we will see all of the methods available inside this. Another point we have to know about like linked list data structure is a linear data structure where the elements are called as node. Okay, basically each node had two fields, one is data and next. So data store the actual piece of the information and next is nothing but the pointer that is going to store the pointer of the next node, similar to the data structure. So something like it will be looks like this. So here it will be like, let's say this is one node. So first node is going to store the data and next pointer is going to store the address of the next node. So again next node would be same, similar to the previous. First here going to store the value and next it is going to store the actual address of the next node. So this is how internally it will be represent inside the memory. So like how we have seen in the array list, it was implementation on top of the array. So basically in the memory it will be like continuous memory location will be there, but in case of the linked list it is the implementation of the linked list data structure. So it is going to implement or going to allocate the memory in the form of the nodes, where first will be storing the data and next it will be storing the address of the next node. So basically this is what I was talking about. So elements are not stored in a contiguous memory. That is how it was happening in case of the array list. So direct access to the element is not possible. If we want to access the element, we have to go one by one to search the actual element. So basically linked list uses the doubly linked list to store the element. So basically there are two types of the data structure, right? Linked list data structure, singly linked list and doubly linked list. So in Java, linked list uses doubly linked list to store its element, while array list internally uses the dynamic array to store its element. So dynamic array in the sense it was internally using the array only, where memory location would be continuously, but dynamic in nature to store the element. And linked list is using the doubly linked list. So it means that linked list is faster in case of the manipulation of the data, okay, as it is node based, which makes it unique. But while getting the data, if you want to get the data, so array list is faster because we will be having the continuous memory location, and since array list is work on the array concept, which is nothing but the indexing concept. So while getting the data, array list will be faster, but in case of the any manipulation like updating the data or deleting the data, linked list will be faster. Okay, so this is how the internal structure would be look like for the linked list in Java. So doubly linked list, if you have knowledge about the data structure, so it would be something like this. It will be having each node having three information. So here it will be previous, next and actual data. So inside the actual data, value will be stored. Inside the next, it will be storing the address of the next node, and similar to that next, previous will be storing the address of the previous node. So each node is having the information about the next node as well as the previous node. So while traversing or while performing the operation, we can go to the either the forward direction or in the backward direction. So both is possible inside the doubly linked list. So similar to that, it is going to provide the same functionality in the Java with the linked list. And similar to the array list, linked list is also not a synchronized. So what do you mean by synchronized? What we have discussed about the non-synchronized context in case of the array list. So synchronized means at a time one thread can perform the operation, okay, but non-synchronized means, for example, let's say if addition is being performed by one thread, other operation can be performed by some other thread also. So this will be useful in case of the multi-threading, right? Because this is not synchronized, it means multiple thread can perform the operation on the same list. Okay, so this is the meaning of the non-synchronized. So linked list basically is a non-synchronized. Now next is how to create a linked list. So there are some couple of the constructors provided by the linked list similar to the array list only. So first constructor is like this. We can create the empty linked list, something like this, linked list, list equal to new linked list. Okay. Another constructor provided by the linked list is like creating the linked list from the collection. So let's say we have already a collection and we want to create the collection, so that while creating the instance of the linked list, the value will be also initialized, right? Because we are providing list of collections. So this is another constructor provided by the linked list, and with the help of this we can create the instance. And last but not the least, the generic way. Like generic means we can create the instance of the linked list, along with that we can provide what kinds of data we want to store it. So this is the most popular way that we usually use across the industry. Since linked list is the extended class of the list interface, right? So this is the best way to create the instance of the linked list or the array list. So we need to provide the interface name, and as a generic we need to provide the types of the data that we want to store inside the list, and then its implemented class. So in this case linked list. So this list is going to behave like a linked list. Okay. Now let's see some of the methods available in the linked list class. So we have seen bunch of the methods are available inside the array list also, right? So but in linked list is going to be available all the methods available inside the list interface, along with its own some methods. So first method like add, that we have seen already. Using the add method we will be able to insert the data inside the linked list. So here there are two types of the add. One is like add with the value, and another add method is like add with the position, means at what position we want to store the element. So internally it will be taken care by where it is want to store. We just need to provide the value and the indexes. Second add method is nothing but the add all method. So at the name itself defined like add all. It means that we are going to provide here collection, means if you want to store the multiple value or the collection of the value, then we will go for the add all method. Next method is like add all. This is nothing but the overloaded method of the add all. So here we will be able to provide the indexes also. So like on which position we want to store this collection of the element. Next method is clear. Clear means is going to remove all the element from the list. Next is clone. Clone is nothing but is going to create the replica of the existing list. Now contains. Contain means it is going to check the provided element is available inside the list or not. Next is, so this is the specific to the linked list method. Since linked list is uses the doubly linked list, it means that it is possible to store the element in both the direction, first or last, or we want to traverse it, we can traverse it in the forward direction or also in the backward direction. So add method like add first. So let's say if we want to store the element at the first position, we will go for add first method. Similar to the add first method, there is a add last method. We want to store the element at last in the list. Then next method is like get method, that is the generic method available in all the linked list classes, right? Get method means we want to get the element based on the position. Then index of. Index of means it is going to return the index, or you can say position of the element available inside the list. Then is empty method, as the name itself suggests, it is going to return the true or false. If the collection is empty, then it is going to return true, otherwise it will false. And last index of method, similar to the index of method, it is going to return the position of the element from the last. Okay, index of method in the sense it is going to return the position of the element from the first. let's say in the list same element available in multiple position. So for index of method is going to return the where it is available at first from the starting position. Last index of means it is going to return the position where the element is available at last from the previous. Okay, similar to that list iterator. So again list iterator is specific to the linked list. Okay, so this iterator is going to help to provide the couple of the built-in method. With the help of that we will be able to traverse the list in a forward direction as well as in the backward direction, similar to the iterator interface, which will be having two important method, right, or two or three, has, next, next, or one more method was there, remove. Similar to that list iterator is going to provide some couple of more methods. Now another list iterator with the indexes, so from where or from which position we want to traverse it. So this is the another method available. Next method is remove. Remove with the indexes, remove with the object, and remove all means if we want to remove every element we will go for this remove all method. The next method is set. Set method is used to update the element. So this is the set method which is going to update the element based on the position. Then size, as the name itself suggests that size means it is going to return the number of the element available inside the list. Then again split iterator, similar to the list iterator there is a split iterator. It is going to provide the more functionality. So don't worry about all these of this method. We are going to see some couple of the example with using some these methods. So don't worry about this all these methods. I am going to demonstrate each and every method in a separate video. Okay. Next method is sublist method. Means if you want to get the sublist from the main list from indexing position to indexing position, then we will go for this method. Then toArray method to convert the list to array. ToArray from the object of the array method. Okay. Then descending iterator. So there are another method available inside the linked list, descending iterator. And then couple of the method elements, get first, get last, offer first, offer last, peak. Since linked list structure is internally uses the queue, right, queue, dequeue. So all the methods available inside the queue data structure also going to be available inside the linked list class. So this is nothing but these methods are available inside the queue. Okay, that is like peak, peak first, peak last, poll, poll first, poll last, pop, push. So these all are methods available inside the queue data structure. So those methods are also going to be available inside the linked list. We will see some example also. Then remove first occurrences, remove last, remove first. So if you see the methods and the naming convention, right, the naming convention itself suggests like what this method is going to do. Like remove first, it's going to remove first element. Remove last, it's going to remove last element. Similar to that, get first or get last is going to return the first element in the list, then last element in the list. Remove last occurrences with the provided object means if there is a multiple occurrences of this object which we are providing, it is going to remove the last occurrences from the list. Okay, so these are some couple of methods available inside the linked list. So if you have already watched my previous video, you can see that some of the methods are common which is available in the list interface and implemented by the array list class and also the linked list class. And there are some couple of method which is specific to available inside the linked list. Like linked list uses the queue data structure also. So that's why it is available peak, peak first, peak last. Means peak means we want to see the element but we don't want to remove the element from the list. Then peak first, similar to the peak, we want to peak first element. Peak means we want to just get the element but we don't want to remove the element. Poll means it is going to get the element and also it is going to remove the element from the list. Okay, so these are the couple of the methods. Now let's see the internal structure of the list interface. So similar to the array list we have already seen. So array list is internally using the list interface. Along with that, it is also using the abstract subsequential class, abstract list class, and array list copy on write class. Similar to that, list is also going to implement all those classes. Along with that, it is also going to implement the queue, dequeue also, right? That's what we have seen. So something like that, we know that what is the uses of the abstract list. So this class is used to implement the unmodifiable list, Means if we want to create the list and we want to initialize at the time of creation only, because there are multiple constructor provided by the list, right? We can create the empty list, we can create the list with some value. Let's say we want to create the list with some value and we don't want to modify that list, or we don't want to allow, or we can say we want to restrict to modify the list. In that case we will go for the unmodifiable list, and we will see there are some couple of methods. Using that we will be able to create the list with the unmodifiable. So internally this class is the responsible that is going to perform those operation, okay, but externally for the end user there are some methods. Within this we will be able to create the unmodifiable list similar to the unmodifiable array list, okay. The next class that is internally implemented by the linked list also, like copy and write array list. So similar to the array list we have seen. So copy and write means this class implement the list interface internally. So it is the enhanced version of the array list in which all the modification like addition, updation, removal, etc. are implemented by making the fresh copy of the list. So this is useful in case of the multi-threaded. So let's say multiple thread is trying to access the element or is trying to perform the operation. So this class is going to help to make the operation on the fresh copy of the list. So it is going to copy the main list into the another list, and there only it is going to perform the operation, so that multiple operation can perform the operation without any problem, okay. So this is nothing but this is going to be implemented internally. For externally we have some couple of method that is going to provide this facility, okay. Now let's see various operation that we are going to perform in today's video. So that is like adding the element, updating the element, removing the element, iterating over the element, then toArray, then size method, remove first, remove last, okay. So now let's go to the IntelliJ IDE and going to perform this all this operation. So these are some couple of the basic operations that we usually do to use in day-to-day life, okay. But in our separate video I am going to demonstrate all the methods available inside the linked list, or you can say array list, okay. So let's go to the IntelliJ IDE and let's go to try to create one linked list class like this and main method. So how we can store the element inside the list? So let's say first how we can create the linked list. So we have seen couple of the ways to create the linked list, but the best way is like to create with the help of the interface itself. So list is the interface and generic also. So let's say we are going to provide some generic information here. Let's say we want to store the integer type of the data. You can create a list with the another generic also, like you want to store the value as a string type, but in this example let's say we want to store the element as a integer type. So like this list and then new linked list, okay. So this is the most popular one, that we need to create the list and then we can store the element inside the list using the multiple methods. So first method that we have seen like add method, right, like list add, and here let's say we want to store 1 2, let's copy paste this one and then store the value different value 3 4. This is the one way that we can store the element inside the linked list, and to print that we can use simply sort statement and then provide the list here, okay. So let's write some statement also so that it will be more visible. So like linked list, okay. Let's run this program and see the output. Yeah, so if you can see element has been inserted 1 2 3 4, right. This is the one way to store the element inside the list and to print the list, okay. Another way is like based on the position. Let's say we want to store on the second position. So how it is going to do? So we will do like something add, and if you see here the add type, there are different types of the add method, right. So this one we have used it, now we are going to use this one. So let's say we want to store on the second position and some value, let's say 10, okay. And now let's print this value again like updated list. Now let's run this program and see. So if you see here index 2 means it is going to insert the element on the third position. Basically indexing started from the 0, so 0 1 2, so 0 1 2, so it's going to insert here, okay. So let's see the output. So So if you see here, it is inserted on the third index, 1, 2 and 10 element, this one, and then 3, 4 automatically shifted. So this is like internally Java is doing all the shifting, all the handling internally. So this is the one way that we can store the element and print it. Now let's see how we can update the element. Like we have inserted the element like 10. Let's say we want to update it with the some another element like 5. Okay. So there is another method available inside the linked list class to update the element. That is nothing but the set. Okay. So if you can see the syntax of the set method, so it is expecting like position and then element, on which position, on what element we want to update. Okay. So let's see, we want to update element like 10. So this is available on third position, right? So let's give the third position here. So 2 means third position, 0, 1, 2, and then let's say we want to update it with the 5. Okay. Now let's print it again, position. Okay, and this is the updated list. Now let's run this program and see the output. Yes, if you can see, it has been updated from 10 to 5. That's what we have updated here. So this is the way we can update the list using the set method. Next operation that we want to perform is like we want to remove the element from the list. So how we can do that? Again, there is another method called remove. Okay, and based on the index or based on the object, in both the way we can remove the element from the list. So let's say we want to use like object. Okay, so which element we want to remove? Let's say 5. We want to remove this 5 element. Let's give the here 5. Okay, and let's print this again with like updated removal, right? So let's run this program again and see the output. What happened? Is there any problem here? Okay, so actually by default it is considered like index only. Okay, so it is trying to index of the 5, but the 5th index is not available, right? So let's give some index like 0, 1, 2. So 2. Since it is the integer data type, so usually if the data is inserted as an integer, we usually go for the index basis, because index value will be as part of as an integer only, and the data is also as an integer. So if we want to try to remove the element based on the object, it will be difficult for compiler to differentiate it. That's why if you want to store the element as an integer, we will go for the index basis. So let's say third position we want to remove the element, that is nothing but the value of 5, right? So if you can see, the element 5 has been removed from the list. So this is the another operation that we want to perform. Next operation that we want to perform is like to iterate it. How we can iterate it? So one simple way is to iterate it like for loop, or you can say for each. So what is the syntax for the for each loop? So we need to use this list, and what types of data is going to return? It's going to return as a integer type. So let's say integer I, and here let's say on each element we want to iterate it, and also we want to add it some value. So let's say we want to add it 10 value on each of the element. So how we can do that? We can do something like this. I value is going to return 1 by 1, and inside the I we want to store like 100. Okay, so let's see the output. Let's print some statement like this, sysout linked list iteration. Okay, so it is going to iterate it, and it is going to print it. Also it is going to update or append 100 value in each of the element. So let's run this program and see the output. So it is going to print like 101, 102, 103 and 104. So this is the way we can iterate it, and also we can perform the operation, right? Next operation that we want to perform is like we want to get the size of the element available inside the linked list. So what is the another method to get the size? That is nothing but the size method itself. So how we can do that? Let's say we want to print the size of the element available inside the linked list. So size of linked list. Okay, so list dot size. So what value it is going to print? It is going to print the size of the linked list, that is nothing but the 4 only, right? Yeah, so it is printing 4. what is the another method that we want to perform? That is nothing but the remove first and remove last. So let's see how we can do that. Let's see, there is a method available to remove the first element or last element or not inside the list itself. So let's see, is there any method available inside the linked list to perform that operation. So let's type like list object and let's see, is there any method. So we can see there is no method. Why? Because we are creating the object of the list type by providing the implementation class. So in this way, this list is going to behave like a linked list, but using this object we will be able to call only those methods which is available inside the list interface and implemented by the linked list class. But what are the methods available inside the linked list specifically which are not available inside the list, we will be not able to call it. So like there is a method called remove first and remove last. Those methods are available only inside the linked list class, not on the list interface. So if we want to use the specific method which are available inside the linked list class, then we need to create the object like linked list, something like this. So now this object will be like direct to the linked list type, right? And then now we will be able to all the method specifically defined by the linked list class. So like remove first. So let's see now that method available or not. If you can see, now this method is available now. Remove first, remove last, remove first occurrences, remove last occurrences, remove all, right? So let's see how we can use that like this. So if you type like this and you will print the output like again, so you will see the first element has been removed already. So let's see like linked list after first removal. Okay, now let's run this program and see. Yeah, so if you can see there, size of the list was 4. Now first element was removed. So what we are getting here is like 3. So the size of the list is 3 because we are printing here size. Okay. Now similar to the remove first, there is another method called remove last, right? Now let's do that also and type here, right, remove last. Okay. Now again let's print this list collection. So let's say remove last. So if you run this program, you will get the actual output. So if you see here, first element was 1 which was removed from the first removal, and when we have written like remove last, so out of this last element was 4, that is also removed. So this is the updated list. Okay. So these are couple of the operations that we wanted to demonstrate in today's video. So we are going to demonstrate each and every method in next upcoming video. Okay. Now let's see what are the next topic that we want to discuss. So we want to discuss some advantage of the linked list and also some couple of the disadvantage. Okay. So what is the advantage of the linked list? To the array list class, linked list also is having a dynamic in nature in the case of the size. So as with the vector, the size of the linked list can grow or shrink dynamically. So you don't have to worry about setting the initial size. So basically we will be able to create the empty linked list, and dynamically if you store the element which is like going to be beyond the capacity of the linked list, automatically it is going to be increased by the compiler. And also similar to that, if you remove the element, and then automatically size of the linked list is going to be adjusted. So that is nothing but the shrink. Next advantage of the linked list is like efficient insertion and deletion. So as we have seen already in one of the discussion, like in case of the manipulation, linked list is fast because linked list is an efficient data structure for inserting and deleting element in the middle of the list, because you only need to change the link, because it is internally uses the linked list data structure, which is nothing but in the form of the node, where each node having the data, and next data will be storing the actual value, and next is going to store the pointer of the next node. So we just need to change the pointer of the node. So in case of the insertion or in case of the deletion, linked list will be faster than the other existing array list class. So this is how it will be look like internally. Let's say we want to insert the element in the middle of the list. So what we can do, wherever we want to store the element, what we can do, we just simply create the node where we will store the value inside the data, and pointer of the node. So pointer of the node we will simply put to the actual node where we want to store it, and similar to that we just need to break the pointer here, and instead of pointing to C, we can point to the next new node. So in this way we will be easily insert the any element in middle of the existing list. Similar to that, if we want to remove that, let's say we want to remove this element, okay, we can do, instead of doing going to every node, what we can do, we simply point we make this pointer to this node to directly this node. Okay. Next advantage of the linked list is like flexible iteration. So we have seen, like, right, linked list uses the efficient iteration through list iterator, right. So in case of the array list, we will be able to iterate the element in a forward direction only, but since linked list uses the list iterator, and using this list iterator we will be able to iterate the collection in forward direction or also in the backward direction. So this is the another advantage of using the linked list. So these are couple of the advantage of using the linked list. Now let's see some drawback. So what are those drawbacks? So first disadvantage of the linked list is like performance. So linked list has a slower performance than array list, because array list work based on the indexes. So if you want to get the element from the linked list, you have to traverse the list to reach to the desired element, because each node having the information about the next node, but that will be not in the continuous manner, it will be somewhere inside the memory. It's just that each node having the information about the next node, so you need to traverse each and every node to reach to the destination, and because of that it is required some extra operation. So this is something like this. So if you want to iterate, or if you want to get the element of C, so we need to iterate from A to B, then B to C with the help of the pointer of the next node, okay, and then we will be able to get the element. Next drawback we can say, like in case of the linked list, like memory overload. So here if you see, to store the each element, it is required to store some extra information like previous node and next node. So extra information is required to be stored in each of the node. Because of that, linked list uses the extra memory. So this is the another disadvantage of the linked list. Okay, so that's all for today's video. So we wanted to discuss like what is linked list, how to create the linked list, what are the advantage, what are the disadvantage, what are the methods available inside the linked list. So in next upcoming video, we are going to discuss another types of the data, another types of the collection available in the hierarchy. So stay tuned, we'll meet you soon. Thank you.